In a previous video, we motivated our need to create a new test where we can compare two populations where we can no longer make the assumption that they're independent. So our example for that was comparing the sales of two different stores in the same city when we're looking at the same days for both stores. So to do that, we're going to need to create a new value. So we're going to create that value called d sub I. And we're going to say d sub I is equal to x1, comma I, minus x2, comma I. And we're going to say these i's are going to be, for example, for using the store example, we're going to say that those are the days. So if we're looking at the sales for the two different stores on day 1, we would say d sub 1 is equal to the sales for store 1 on day 1 minus the sales for store 2 on day 1. And we're going to turn all those di's, so for each of those differences, we're going to turn that into a new value. We're going to call that d bar. And d bar is going to be defined to be the sample mean differences. So we're going to use this as our new value that we're going to create both test statistics and perform hypothesis tests with that value. We're also going to need S sub d, and S sub d is just going to be the sample standard deviation for our differences. And the last value that we're going to need to have is N sub d, and N sub d is going to be the number of differences that we have. Or if we want to look at it another way, we can call it the number of pairs that we're comparing. Now let's just take a quick look and see how we can actually create confidence intervals for our new values. So we're going to create a confidence interval for d bar. So we're going to say d bar plus or minus. We're going to do z sub alpha over 2 and multiply that by our sigma sub d over the square root of n sub d. And if we look at this formula, we see that this is the same formula that we were using originally for our confidence intervals, where if we had x bar plus or minus z sub alpha over 2 times sigma of x bar over the square root of n, that's the same confidence interval that we've used in the past. So if we also don't know what our sigma is, we can substitute in s, so we get d bar plus or minus our z sub alpha over 2 times sd over the square root of nd. And again, that's for our large sample. And it's again our CI. Now if we want to do our small sample CI, we just use the t statistic, and we would get d bar plus or minus our t sub alpha over 2, because again, we're doing the small sample. And we're going to have our SD, since we don't know our sigma, over the square root of ND. And again, this is for our small sample. And if we actually need, and since we're using our T sub alpha over 2, we need to know the degrees of freedom for that. And we're going to say the degrees of freedom for T sub alpha over 2 is equal to our ND minus 1. So the number of differences that we have, minus 1.